In this video, we shall learn about query optimization. So, query optimization is generally like, let's say you're having a query and it is taking too much and it is running very slowly. So, then that's the time you need to optimize the query. So, in this thing, in this particular video, we will try to see in what are the ways to optimize a query and all things like that. So, first thing first. So that is this font is way too big. Yeah, now it's good. So we will use explain explain keyword in front of our query to see at each step what scan is it doing, either is it sequential scan or is it index scan or is it, and also we need to see if it is doing high row estimates. Let's say like is it taking all the rows to uh, run your query, is it using only some rows? That all depends. So yeah, if we say here, let's say if there is a sequential scan, it is bad on large tables, right? And what about index scan? It is good. And if there are high row estimates, we try to see use some filters. And we can also use explain analyze to see the time details also. I don't know. Yeah, that's the thing. So one more, let's see the optimization techniques. So we try to use indices, try to use index for columns where we often use, where we often apply, where, join, and order by. And one more thing is like avoid select star. You try to fetch only those columns which you need. Don't unnecessarily fetch all the columns. And try to limit the output, limit x, something like that. Don't fetch all the million rows of data. One more thing is avoid functions on indexed column. If you avoid functions, that index will not be applied. If you, let's say you have some name and you have indexed that, and while querying, if you use where lower of name equals to something, so you applied a lower function there. So what happens? The indexing doesn't work there, and as usual, this query will be very slow. And now we shall try to see how to optimize the queries which is containing join. First thing is like in joins we will try to join with respect to the foreign keys, right? So try to index foreign keys. First thing. And what else? Reduce join size. How will you reduce? Before applying before applying join, apply filters. Consider denormalization. When? When is it? When do we use denormalization? When writes are less and reads are more, right? So when writes are less, the data is almost like constant. Then why to use different tables? Try to use them in the two same table itself. That is what we call it as denormalization. So that is what it is. Denormalize is nothing but making centralization. That's it. And fourth one will be using proper joints in left, right. Accordingly, we need to use. Don't use whatever it is. So we shall see common anti-patterns for this query and query optimization. First thing is n plus 1 queries. Where this is a famous thing. Like what generally people do is like, let's say let's say we have orders, and for each order ID we want to fetch its price. So what what is this n plus 1 issue queries is something. So first user will fetch all the queries from the table, like let's say query IDs. So this is one query. First query is select order ID from select order ID from customers, let's say. So you will have this many lists. Now what all other n requests will be like, select price uh, from orders where order ID equals to order ID, let's say, and this will be uh, for order ID in ORDR underscore IDS. So something like this it happens. So from this we get a list of, from the first query we get a list of n order IDs, and then we try to do n separate queries. So this is what generally people fall into. So instead of this we can use a clause here, the in clause. Better to use in clause. That is like here what we will try to do is like order one second. We can use something like orders in order IDs. Something like this. This helps. See, here data first we are requesting the database, again we are getting the request, again we are requesting, again we are getting response, something. So with only one request and response is way faster than getting multiple requests and multiple responses. So that's the main key here. So one more thing is like on or on different columns. So let's say you use something like where a equals to 2 or b equals to 4. What happens here? And let's say a and b are indexed. Do you think that here these both indexes are used? Ideally the user intent is that this query especially should use the index for a equals to 2 and b equals to 4, and then finally merge the both results, right? So if we do something like that, what happens? So generally most of the databases, again I'm saying most of the databases, not all, what they prefer is like they go from left to right. First they will try to filter according to that. First they will filter with that index from the first thing a equals to 2, and then they will do the database lookup for the second one. So in order to avoid that, what we will try to do is like where a equals to 2 union where b equals to 4. Obviously this is not the correct syntax, it will be like select a star from some table. Wait, I'll from some table. And here also you will have similarly select a star from some table. So something like this. This is better. This what actually does here. Here it uses the index. Here it uses the index, and then finally merges. And one more pitfall is that people use like percentage some value and some percentage something like this. People use it. So what happens here is we either need to use full text search, because full text search on the particular column works as same as normal indexes, but whenever you are using like, that index doesn't work. So this is one thing. And what about other thing is like pagination, that is what limiting the rows. If we don't limit, or if we don't do the correct pagination, and you will get multiple not millions of things, and it will obviously increase the latency. Yeah, so that's all for this video. This is what about query optimization. I think you have a very good idea from this video. Thank you.